How is this possible? So without using the table, how is it possible that we can figure out the equation of the line without making the table? It is possible. What do you think? What do you think? What's a way, without making a whole table from everything, what could you do without making a table? What piece of information do we need to know to make the equation? That's a big question. What piece of information do we need to know to make the equation? We need to know what? What things do we use to create the equation? Okay, what things, what pieces of information do we need to know so we could build the equation? What things do we find? What are our steps that we find to do the equation? Think about what we did. What are our steps? When we were doing it yesterday and finding the equation, what was the first thing we had to find? So let's write the general format. Let's see. We need to know y equals, what goes after the equal sign that we have to find? What goes after the equal sign? What are we finding? What are we finding for our equation that we stick to the x right after the equal sign? So y equals growth, x, and then what do we find? Then what do we find? What goes at the end? Plus what? What goes after the growth? What goes after the growth? The starting value. Yes, thank you. Okay. Oh, I forgot that. 1 second. I'm not in a text box. I have to fix it. Y equals growth, right? Times the x plus the start value. I can spell some days. Right? That's our rule. Y equals growth x plus the start value. So could I get the growth from the graph without making a whole table? Can I get the start value from the graph without having to make a whole table? So what did we say growth was? When we say growth, and we've defined it a few times, what is the definition of growth? How do we find growth? What do we do to find growth? Look, 2 days ago, even. What are we using? Okay. So when we go to find growth, I know. We wrote down multiple times. Growth is, what are we using to find growth? So let's go look at our previous worksheets. Let me bring up one of our previous ones. When we had to find a rule, not that one. Oh, right here it has it. What is the growth? What are the pieces that we use to find growth? Okay, that's what I'm asking. What are the pieces that we use to find the growth? Now I have to go back and find the one I was working on. There it is. What are the pieces we use to find the work? Aha, is it that we use the change of X and we use the change of Y? Yes, but how are we using them? Who goes first? What does what? So we have to look at the changes, but then once we know the changes, what do we do with those changes? Once we look at the changes, what do we do about them? Go back and look at Tuesday's note. It was in parentheses after the word growth. Go back and look at Tuesday's notes in class, chapter 4, activity 2. It was like down on the second page where we were finding growth. What did it say? What do we do with growth? We have to do something with the change of the X's and the change of the Y's. What are we doing with those changes? Once we find the changes, what do we do with them? Divide, but who divides what? I need to know the specifics. We need to be getting into specifics by now, guys. What about who divides what? What divides what? So go back to Tuesday's notes, open it up and look at them. It's on the second page. I found it on the second page. We set it in parentheses after the word growth. We've done it for several days now. What do we do with the growth? How do we find the growth? What do we do with these changes once we find the changes? We divide, but who divides what? Which is like, so we do the change of Y divided by the change of X. We've done that several times, right? Okay, we've done that several times. So we can find those changes on the graph. We can find those changes by looking between two of the points. So let's go put some coordinates on here. What is the coordinate for this bottom point? Let me make this a little bigger. Okay, what is the coordinate for this lowest one here? What are we going to say its coordinate is? Mm-hmm. 0, 1. Okay. That's that coordinate. What about the next one up? What's that one's coordinate? One comma 4, right? Can we find the change in the y's and the change in the x's using those two? Do we have a way to do that? Yes. So we need to find out, and I want to actually move the second one to the other side. If you notice, they drew this cute little triangle in here, right? This is called the slope triangle. It's called the slope triangle. For our purposes, it's our growth triangle, okay? And all we're gonna do is we're gonna count how much change there was from the one y to the next. So we're counting how tall is this triangle. How tall is that triangle? Okay. How tall is that triangle? That'll tell us how much our change in y is. This triangle, this little tiny triangle right here is 8 tall. That doesn't seem right because I'm only going from 1 to 4. Oh. And then I have to see how wide it is. That's going to tell me my change in x, how wide it is. Okay. Now, was it a positive 1? Did it go from a smaller number to a bigger number? Was it a positive 3? Because it went from a smaller number to a bigger number? Yes. So you need to make sure you're doing your signs on these too. So that went, I added 3 to that one and I added 1 to that one. So now we can do our go ahead and find our growth. Let's go ahead and find our growth now. Growth equals positive 3. That's the change in the y. Oops. Over positive 1, just like we've done over and over. What do we get for our growth? What do we get for our growth? Because positive 3 divided by positive 1 is not 4. Not 4. Because we divide. So if we're dividing, what do we get? We get a positive 3. Yes. Okay. So our growth is positive 3. So we could start our equation. Y equals positive 3x, right? Positive 3. So we're starting our equation. Y equals 3x, and then we have to find what? What comes after finding growth? What comes after finding growth? What comes after finding growth? What do we need after we find the growth? Starting. Okay. How do we know a starting point? How do we know a starting point? How do we know on a graph the starting point? Where on the graph is the starting point? Where is the starting point? What is the giveaway? How do we know it's a starting point? What do starting points look like? If it was on a table, what would we be looking for? We'd be looking for the part where it's x equals 0. So we need the starting point. Which is the x equals 0 spot. So for this situation, our starting point is 0, 1, right? 0, positive 1. So I finish off my equation by saying add 1. Okay, now we got to do the sentence part of this because they asked, how is it possible? So how is it possible to get an equation from a graph without having to make the whole table? What pieces of information did we need to know? To get the equation from a graph without a table, what do we need to do? We need to. What did we do? What did we need to do? So what did we just do? What did we do first? What process did we just take? We are explaining it now. So what process did we just do? What did we do first? Come on, I got a couple people that aren't showing me their eyes, and I know it's because they're confused and they don't want their eyes showing. But that doesn't help me help you. So please fix your cameras. What did we do first just now? We just got done finding an equation from a graph, right? What was our first step? What did we do first? What did we do first just now? I purposely walked us through the steps before we had to explain them. We did not make a decimal. Nowhere is there a decimal on this page. What process did we just take to find that equation? We found the growth. How did we find the growth? Here's the equation. How did we find the growth? What did we do this time to find the growth? What did we do differently this time to find the growth? Look at the work we've already completed. Look at the work we've already completed. How did we find the growth this time that was different? What did we add to the picture so that we could find the growth? What does this graph have on it that none of the other ones had that we used to help us find the growth? Look at this graph. What was added to the graph that helped us find growth, guys? Come on. What was added to this picture to help us find growth? Ah, the generic triangle. Yes, the slope triangle. We found the growth. We need to find the growth by drawing in the right triangle. I can spell triangle from the first point to the second point. Okay, now, what did we do with that triangle? The sides of the triangle gave us what? What did the sides of the triangle give us? What information did we get because of the sides of the triangle? So Moses, you're partly right. What is it that that +3 got us? We had to find the sides of the triangle. What information are these numbers, these sides of the triangle? What is that information? What was the +3 standing for? What was the +1 standing for? That we already wrote down on this paper and it's sitting right there in front of us. What did the +3 stand for? How did I use it? I used it on the top of this fraction. What's supposed to be on the top of the fraction? It says right here what goes on the fraction. So what did the +3 stand for? What did those numbers stand for? What makes up growth? What does the top of the fraction stand for? What did that +3 number stand for? What did it tell us? What were we solving for with that +3? Okay, the growth is the whole thing. We need to know the one tiny piece, top of the fraction. That's what the +3 was. What part of our growth was the +3? Look at the definition. Oh, what about the y? Not just the y. What about the y? The change of the y. Yes, it gave us the change of the y, height, and change, I'll move in a second, of the x, base. Okay, so the height gives us the change in y. The base gives us the change of x. Okay. So to get the equation from the graph without the table, we need to find the growth by drawing the right triangle from the first point to the second point. The sides of the triangle gave us the change of the y, height, and the change of the x, base. Then, after we knew the growth, what did we look for? What was our last piece of our equation finding process that we looked for on the graph? After we know the growth, what do we look for? What do we need to finish off? camera. The starting point, and we would be looking for what kind of point for the starting point? What point are we looking for on the graph? What are we looking for the start point? We're trying to find where. What kind of coordinate are we looking for? We're looking for not just 0, 1. 0, 1 was this particular one. What? Oh, we're looking for when the x is 0. Yes. Then look for x equals 0, because why do we need the x equals 0? Why? What about that x equals 0 is important? If I have a 0 comma number coordinate, what is that for our equation? It's this 0, 1 was what piece of our equation? We have two pieces, growth and what? Okay, so we look for x equals 0 because its y value is the starting point. Okay. Alyssa wonders if she can use the idea of M and B, we'll talk about that, to find the equation of the line from the table. So now this M and B stuff that she's talking about. M, when they say M and B, M equals growth, and B, like we learned yesterday, equals beginning, which is your start value. Okay, so we found M in the growth. We're going to add that in here now. Growth is now called M, and start point is now called B. Okay, so our general format goes y equals, let's get the thing working, y equals mx plus b. And I want this to be in an equation, not in a text box. Okay, because m is my growth and b is my start value. Okay, so she wants to know, could she use that growth remember this one's growth, and B, our beginning, our start. With the table. And the answer is yes, because that's what we've been doing, right? We've already been doing that. We just didn't call it M and we didn't call it B. We were doing the process without calling it that. Okay. So we're going to find the equation using the table. She's done this before. We've done this before. She is telling us our change is +5. So we're making the equation. We're making the rule. Equation equals rule. Do I need to put that in there too? Because I'm thinking some of you might be getting all mixed up, because equation equals rule. Okay, She wants to know if she can use the idea of growth, M, and start value, B, with the given table down below to make the equation, which is the rule. Okay. So is there enough information using the table that's here to write the rule for it? Is there enough information that's already marked to write the rule for it? What do you think? Do we see a start value on this table, which is B? Do we see a start value on the table?
Okay, you good? Hello?
Okay. Do we see a growth pointed out on this table, even though it's not filled in? Yes. So do we have enough information from what we see to make the rule for this table? Yes, because we have all the pieces. So the question is, how can she find the equation of the line from this information? So what's her name again? Alyssa? Alicia, I think it is probably. Because Alicia can find the equation, which is rule, from the information given with this table, because how can she find it? What did they give her so she could find it? What did they give her so she could find the equation just from what she sees? The growth and the start value. Because she can find the start value, and for this situation, what's the start value going to be? What is the start value going to be? You said it's there. Yeah. Start value is going to be the 0, -2 point. And the growth of, what's our growth? What's the growth they're showing us? +5. Now, do we need to worry about that's the change in Y, right? Don't we need to know the change in X? The +5 is the change of Y. How can we find the change of X? What do we see the change of X is? They didn't do this piece for us, did they? And I'm seeing people who are just drawing these lines and thinking that's good enough, and it's not. You actually have to solve what they are. What's our change in X? How much did it change for the first 2 coordinates? What was it changing by? Adding 1 to that coordinate. Okay, keep going, look at them all. Are they the same? Did they all go +1, +1, +1, +1, +1? Did they all go +1, +1, +1? Yeah. So we could just do paste, copy. Oops. Come over here. Paste it. I'm going to move in a second. For each one of these bridges, I have to paste one. And then I'll move it. Give me a second. Paste it. Paste it. Okay. Now I can move them so I can see them. There's that one's +1. Here's this one's +1. Each of these bridges gets its +1. Okay, so we have the change of y, and we can solve the change of x, which was +1, right? We good? We understand? So now we're going to do it. What's the equation? We solved the change in y, we solved the change in x. We need the equation now. What are we going to say the equation is? The equation for this situation is, what is the equation? What was this? What was the growth? What was the change? Make the equation. Y equals what? Y equals what? What's our equation based on our growth and our start? What would we say the equation was for this situation? Based on our growth and our start, what would we say our equation is for this situation? Yeah, -2. Yep. Y equals 5x minus 2, because the start was at -2, right? Our start, our two pieces of growth. Now, it was an easy one because the growth for the x's was going by 1, but you can't assume that. You can't assume that. We need to quickly go fill in the table now. We need to quickly go fill in the table. If I'm adding 5 to -2, what would I end up with? Because it says we have to complete the table and find the rule. We found the rule, we did our explanation, we're now completing the table. If we take -2 and we add 5 to it, what are we going to get? Three. Okay, now we go to the next one. Keep going. What would the next one be? 8. Okay, what about the next one? Yep, 13. Keep going. We're getting it finished almost. 18. If you will type for me. Okay, then what? 23. Then what? 28. So we read the instructions. Did we explain how to find the rule from the table? Did we, because it asked us, can we find the rule from the table? Did we answer that for this question? Okay, did we solve the table and find that rule? Okay, some of you are not fully reading instructions, so you're not getting full credit for your homework. Happened a lot the other day. Okay, using that idea, we're going to find our rules for these tables. Tell me what to do first. What do I do first? What do I do first? Whenever I'm got a table and I'm solving for the equation, what's the first step we got to take? We've done it lots and lots. What's our first step that we have to take? The start value is where we begin our equations? Are you sure? Because it doesn't feel like what we've done in the last few questions. Oh, we have to find the growth. So what is it that we do so we can find the growth when we have a table? What is it we do so we can find the growth in the table? How would I visually show I'm finding the growth in the table? What am I visually adding to the table so we can show the growth? What do I visually add to my table so I can find the growth? Well, what do we add to the table to find the growth? What have we done over and over, even just above, to help us find the growth? What thing do we add to the table so we can find the growth? What do we draw in so we can find the growth? The lines, yeah, we draw in the lines. We find the changes. Yes. So we got to draw in our change lines. We got to draw in our change lines. All right, so change lines. Make sure you're like a 1. Some people are trying to use 6s and stuff, and it just doesn't work the same. Change jumps. Okay. Do they have to be pretty? Absolutely not. Mine aren't. We're just saying that we're changing what's going on. I'm trying not to keep them too big because we have the one right below that we're going to have to do. Okay. We're making connections. What's happening math-wise? Okay. Once we got our change lines in, we're going to go do the math. What's the growth change happening on the top level? What's happening over and over on the top level? We're adding 1, because from -1 to 0 was adding 1, from 0 to 1 was adding 1. Over and over, it's adding 1. So I'm going to go above each of these and say +1 by just doing a paste. Write it the first time, paste it the second time. Work smart, not hard. Okay, and then you just go shift them so they're a little better after. Don't worry about the positioning until you got them all copied and pasted. That one still shows up okay. Okay, now we got to go do the bottom. I'm going from 3 to 5, from 5 to 7, 7 to 9, and so on. So what's happening over and over on the bottom? We're adding 2. Okay. That goes to the next group of changes. And I'm pasting 1 for each change connection. Then I'll go move them around. Just got to get them on the page first. Okay. +2. Move this guy up. +2. I just have to make sure each of my pairs has its +2. Right? So what have I just figured out? The change in y and the change in x. So what is that going to give me for my equation? What do I get to go solve now? Because I know the change of the y and the change of the x. What do I get to go solve for now that I know the change of y and the change of the x? What piece of our rule? The growth. Okay, so growth, which is the m, which is change of y divided by change of x. My change in y is +2 divided by +1 to find that I have a growth of how much? How much is my growth for this situation? What's this equal? +2 divided by +1, what does it equal? +2. So we have the m. Now we have to go find the beginning. So we look at our table. Where is our table beginning? What does it look like when we have a start value of beginning? What are we looking for the start value beginning? What are we looking for on the table to see where we begin? The x of 0. So for this, where are we beginning? Oh, 0, 5. Thank you. Now 0, -5, 0, +5, what? +5. Okay, 0, +5. So now we have everything we need to build our equation, right? We know our growth, which goes with the x. We know our start, which goes at the back. So y equals 2x plus 5. No, yep, 2x plus 5, because our beginning It was right here. We're always looking for where the x is 0. Let's go do the next one. Okay, we make the connectors. Boom. If you do them quickly and you don't think about it, you're more likely to get decent ones. Once you try and think about it, that's when your hand goes, oh, nope. So if you just do them super quick, they tend to come out a little bit better than if you're trying to be special about it. Okay. So what's our change going on along the top? What's happening over and over and over on the top? Adding 1. Yep. Okay. How about the bottom? Okay. So we have our over and over add 1. So I'm going to just go reuse this guy up here. Okay. Put it down here. Add 1 over and over and over. That's what's going on. And the bottom's going to say -3 over and over and over. Let's go copy and paste those in. I personally find sound effects make life a little more fun. Some of you are just drawing the lines in on the tables and you think that's good enough. It's not. You lost points for that. Because I have never just drawn the lines in and not done these plus and minus stuff on the, okay. And the bottom is a -3. So I'm going to put 1 in and then change it to what I want and copy that one. Two. Okay, and I'm moving around. This guy's bugging me. He's a little low. All right, good enough. So we're going to go get our growth. So growth is now called M. Right? That's our change of Y divided by change of X. So we're going to go get that. And it was a -3 for Y divided by a +1 for X. What value is that when we end up doing the math for it? What's the value for it? If I do a -3 divided by a +1, what do I get? If you hit the undo, you should be fine. -3. Okay, that's our growth, -3. Where's our beginning? Where's our start? What is our start value? Mm-hmm. 0, +7 right here. We always look for where the x is 0. Okay, 0, +7. 0, +7. Why does the sign matter? Because when we go to do the equation, we need to have that plus or minus to help us finish. Because remember, our equation has pluses and minuses at the back. Okay, so my y equals -3x plus 7. Okay. 1. Move him in a second. Nope, I'm going to move him first. Undo that. I don't like that he's down in the words. 2. Okay. Write a summary statement explaining how you used knowledge of M and B to quickly write an equation. So, how did we use our knowledge of M? What does M stand for again? Okay, we used M, which is our growth. Okay, and B, which is our what? Start value when x equals 0, right? To make the equation, what's another name for an equation in this situation? Rule. In the form y equals mx plus b. That was it. Okay, so now we have a new way of saying it, but it's the same thing we've been saying all along. Find the growth, find the start value. Same thing we've been saying all along. Okay. Questions about that? Questions about that? Okay, hit turn in. Now, I do know for some of you, when you go up to this save spot, it says turn in. So you need to click that turn in and also the Google Classroom turn in. I found out they don't necessarily always go when you only click the turn in that's here in the save feature.